Hello everyone. This concept is Introduction to ADTs. Earlier to this concept, we were discussed about concept of abstraction, and we come to know there are two kinds of abstractions: process abstraction and data abstraction. So this video will be going to talk about process abstraction in detail. Okay. Now, so process abstractions I'm going to call with the name of ADTs, abstract data type. Okay. Now, the evaluation of data abstraction began in 1960 with the first version of COBOL. And COBOL is a programming language, and it uses records to store the information of the program, or else COBOL programming will get constructed through records. We will be taking records to construct the COBOL programming. For more detailed clarity, you can watch the video of COBOL. Okay. Now, the C based languages have structures which are also records. The way how we will use structures in the C programming. In C programming, for this also, as I specified, for each language we have a separated video that you can watch it for the better clarity. Now, how abstraction is being provided for this structure is, we will be taking one blueprint of the structure. That is, if I wanted to create a book as my structure, we will take some attributes, correct? Book name, book ID, something we will take. And if I have book object which is of B1, now whatsoever things I created in this structure, that all will be applicable here B1. I'll not specify again what B1 is going to have. So C based languages will be providing this abstraction, process abstraction through structures. Now, so we'll give a definition what exactly ADT is. One formal definition, one syntactical definition. Formal definition is what? An ADT is a data structure in the form of a record, but which includes subprograms that manipulate its data. It is what formal definition. And one syntactical definition is also given for an ADT. An ADT, abstract data type, is an enclosure that includes only the data representation of one specific data type and the subprograms that provides the operations for that type. Through access controls, whatever subprograms we were given, unnecessary details of the type can be hidden from units outside the enclosure that use the type, even though the actual representation is hidden from them. This is a syntactical ADT. We'll see an example of the syntactical ADT definition. Understand here two things. One is representation, what I'm using the word, and second is I'm using the word which is implementation. Correct? Now this is what actual representation it is termed as, but generally we will be talking about two things in ADTs. One is representation and the other one is implementation. So we will take an ADT where we will give data representation of one specific data type and the operation what it performs. Through the access controls, unnecessary details of the type can be hidden from the units outside the enclosure that use the type, even though the actual representation is hidden from them. What do you mean by actual representation? How it will be implemented? What do you mean by representation? What are the data types of the variables and what operation it performs? It is an ADT. An instance of an abstract data type is called as an object. Example. Now let us take some example. A program needs to sort an array of numerical data of some type. Assume this for the better understanding. It usually uses a subprogram for the sorting process. So I am calling it is a subprogram. So what I am talking? I am talking about process abstraction. So this example is what? Process abstraction. Now, when a program needs to sort an array of numerical data of some type, it usually uses a subprogram for the sorting process. At that point where the sorting process is required, a statement such as this function name or subprogram name and the variables of that type, and this will be is placed in the program. This call is an abstraction of the actual sorting process whose algorithm is not specified. This call is independent of the algorithm implemented in the called subprogram. In case of the subprogram sort int, the only essential attributes are the name of the array, and the name of the array to be sorted, the type of elements, the array's length, and the fact that the call to sort int will result in the array being sorted. The particular algorithm sort int implements is an attribute that is not essential to the user. The user needs to see only the name and protocol of the subprogram to be able to use it. Right? Now, here in this, we will be understanding the subprogram name and the variables which are I'm going to take, that what an array type, what is the data type of this elements, and what is the maximum size. These things are going to be shown to the user. So this is what we are representing, what operations it is going to perform, but we are not representing how the operations are going to be performed. In other sense, this ADT, now sort int I can call with the name of ADT. Why? I'm specifying what it contains, but I'm not specifying how it implemented. So now this is called as an ADT. So this video, or else this concept, is talking about process abstraction. How I can make view to other enclosures, to other users, to see only the process where implementation is not being included. So this is what process abstraction. So we will be declaring the process what to be performed. We will be calling the process what to be performed, and somewhere in the program we will be writing the implementation part. Correct? But this thing is called as an ADT, as I am not implementing any code over here. So you can say this, every calling procedure, every calling subprogram is an ADT. Process abstraction means this. Thank you all.